Okay, so now we're downstairs in the 7th floor core facility. So this is the TSQ Altus. This is the triple quad that we run all of our samples on. And so there's other people that use it. So more often than not, it's not just going to be ready for us when we get there. So once you log in with your username and password, you're going to open up this software here called Excalibur. And so this is the main screen of Excalibur. So Excalibur controls both the mass spec and then also the liquid chromatography platform on the left. So before we're going to have to install our column on this, and so before we do that, we want to turn off the flow because this is always running at a very low flow just to keep the system flushed out. So we're going to click here for thermoscientific S2 for Excalibur. And you'll see some like information pop up, like it says like the sample compartment temperature, the column temperature, and it shows the current flow rate and pressure. So we want to hit direct control. We can see it, pulled up this new screen here. So we're going to turn the flow rate off. So we're going to just hit the down arrow. It should go to 0. You can see the pressure here is dropping, so that's good. But the other thing we're going to want to do too is, let me just check to make sure this is the right lines. Okay, so you can see before on the other screen it was set to A2, B2, so it's using these two bottles here, which is methanol and water. We don't want that. We want to use the water with formic acid and the acetonitrile with formic acid. So these are on lines B1 and A1. So we'll come back into our software and we'll click this, pull down here, and we'll go to A1 and B1. Okay, so now it's gonna, when we eventually run, it's gonna pull from the right bottles. Okay, so it's all turned off. Part of the reason that we turn it off is that most of the compartments in an LC have a leak detector. So down here is a little leak detector. So if any liquid gets on that, it shuts the whole thing down, and it's very hard to dry it out once it gets wet. So it's just easier to prevent that from happening than to deal with it. So the column that's in here is like I think it's just like a dummy column that they use to just have something connected in there. And so there's these little fittings on here. They're called Viper fittings. They're very loosely attached. There's just kind of like a little slit that they slip through. So they're very easy to like this one usually falls off. I'm surprised it didn't already. But this allows us to hand tighten everything, which is really convenient because on some systems you have to use like a wrench. So we'll take this column off, and we always want to plug up a column because we don't want the inside to dry out. So I'll just find a couple of plugs up here. Okay. And then we're going to get our column. This one here. Popeye. So we run so much spinach on it.
Oh.
Put that there. So this is our column. So I just took the little end caps off. And so our column comes with a little like electronic fob on it. So on water systems, you plug this into a little magnet and it stores information about the column's history and stuff. So this doesn't have that, so we just have to keep it outside. So what's important though is that columns usually have like a direction that they go. So you can see here it says flow. And so we want the liquid to be going, from here to here. So you can imagine this is our LC. So the liquid's coming out of the system. It's going through. Kind of open up a little cabinet here. Going through this valve, it's coming out here, it's going through here, comes through here, then goes through the column, then goes into the mass spec. So that's the direction of the flow. And again, you just have to hand tighten these. There we go, there's one. And then at the end, I usually just grab both of them and turn them both, I guess, clockwise in their respective directions. And then This is optional. It doesn't really like fit on these columns, but it kind of just helps keep it inside the center here. Let's pop this electronic fob thing up there. Okay, and then to close this, you can see this is on like kind of a weird like swivelly thing. So you just have to line up the latches and then lock that in place and then shut the outer door. So okay, so our column's installed now. So we can start running some our mobile pages through it. So I like to just start at like 0.1. We're also going to turn the column heater on. So our method, I believe, is at 40 Celsius. So you can see this temperature turned red because it's not ready yet. So it's going to slowly start to heat the column. And even once it gets to the right temperature, it's going to take a few minutes for the column to actually warm up. Because it takes some time for that heat to kind of get in. You can see now, like our pressure, just from going to 0.1, our pressure is already, a lot higher than it was earlier. And as we just leave this here, it'll slowly start to like creep down as the column heats up. So before we do anything else, we're going to prepare our batch file. And so this is going to be like a set of instructions that the computer uses to run the samples that we're going to add in today. So what I like to do is, since we're running something that's like kind of similar to what we've done in the past, I'm going to open up an old one. So this is one from the other week. And I'm going to save this as a new file. Today's 12/12, and we're doing So one thing that's nice about, you can technically edit your batch in the Excalibur software, but Excel has some nice like tricks that you can use to like quickly edit stuff. So like for example, it's not 12/6 anymore. So what I can do is I can go Control F, can hit replace, and I can replace all these with the correct date. Okay, awesome. So we're going to keep all this stuff. So this is our standard curve. I might even throw in, I'm going to throw in another blank here because I remember last time there was like a little bit of, I'll do a couple blanks. There's a little bit of carryover. Just going to do this. Okay. And so basically this is set up exactly the same as the batch editor. So this is our sample name. This sample ID, I'm not quite sure what that actually does. So the path is basically like where it's going to save the file to. So we're going to make a new path here. Say 2024 12/12. We'll call it flavonoid method testing. Copy that. I'm just gonna copy that down. We don't need all of these samples. I think today we have, how many samples do we have? We have like 20 something maybe. 8, 16, 35, 37. Okay. So we only have 37 samples today. So everything below here I'm just going to delete. Okay. So we've set the path where it'll save. The instrument processing method, so in this case, like, or the instrument method, this is like the chromatography and the mass spec information I'll use. Oh, 38? Okay, thanks. All right, so so this is all like, we happen to like use this method, so like this, like we can keep that. That's all correct. And then the processing method should be correct too. So that's great. Okay, and then this is the like where it actually looks for the sample. So in this instrument, they have different colors for the individual plates that are inside. So this is the green plate. And then in this column, this is our injection volume. So for the most part, we always do 5. Every now and then we do 7.5 for some of the blanks or like one of our stock solutions, but this is all going to stay the same. And then we just need to add, so it's 38 samples. Okay, yeah, we just need one more. D4, okay. So in our case, like we have, these are gonna be our samples. So these are the leftover sample IDs from a previous run. So I'm just gonna change these, so it's just the date. And put this up here. So yeah, if you look in here, you can kind of see like the plates have like a different color. So this is the blue plate. This will be the green plate over here. So this is what we're going to work with. And if you have the software open, I recommend never closing the door all the way, because when it detects that there's a plate missing, it freaks out, and it's just easier to not deal with that. Okay. So we've got our, this is just a methanol only blank that we're going to put in A1. So it'll be designated as GA1. So that's our blank. And then after that, we have our standard curve that's going to go in. And actually, I'm going to add one more here. Let's see. So we have our 6561 standard as well. Oops. And I'm going to put that in. I'm just going to have to put that in a weird place. I'm going to have to do D5 in this case, which is kind of weird. Actually, you know what? Let's just make this right. So I'm going to move this up. Yep. Okay, so A2, 3, 4, 5, 6, 7, 8, 9. And then our stock is going to be, B1. And then all of these will just have to shift down one. Make sure that's right. Looks right. All right, so now let's start loading it up. So we've got our standard curve down here. We have our 6561. Now we already flicked these earlier, but it's just good to double check. Just look at it, make sure there's no air bubble at the bottom. So 6561, then our 2187X, 729, 243, 81, 7, 9, 3, and our stock B1. Yeah, that looks right. Perfect. Okay, and then our first real sample will start in B2. So we've got the real samples here. So we've got QC16.
Can we pick these randomly, right?
Yeah. And they were also like put away randomly, so I think it'll kind of work out. QC14. QC12, QC15, QC18, we've got QC23, QC27, QC11. All right, then we got internal standard. QC24, QC13. One thing I'm doing is every now and then I'll just double check and make sure Okay, this is in C3, green C3. This is going into green C3. So just making sure that there's no like, like frame shift issues with our sample locations. I'm going to make a few more, but discounted. So we have 4 here, or we 7 more after this. Take that in. And then this is going to be D6, 7, 8, 9, 1, 2. Okay. I see that. 1, 3, 6, 4, 5. Okay, now we've got our full batch list ready to go. So we're going to hit save. Close out of this. Okay, so one thing that is kind of like important to do for like this system, so it has some weird memory glitch. So if someone's run a bunch of samples on this, and then you go ahead and run some samples, sometimes it gets kind of like clogged up with, it gets kind of like clogged up with just like old information. So there's this like trick you have to do. I'll show you. So you have to get this, it's a paper clip. Now it's a thermoscientific mass spectrometer reset pin. And so you're going to come over here. And it's just like tiny little dot right here. You can see there's like a little button in there. It says reset. So you just hold this for a few seconds. Oops. Okay, that's it. And now we restart the computer. Okay, so we just restarted the computer after doing the system restart, or the mass spec restart. You can kind of see here, like, normally there's some like colors here. You can see there's like, it's just kind of that green button, or the green light indicating that the power's on, but it's not showing anything else. So if we open up this TSQ console, you can see up here it says disconnected, which is normal. So right now, it basically means the computer is not talking to the mass spec yet. So you just have to give it kind of like a minute or so, and you'll start to see, like, it'll say like, oh, it's booting up, and it's doing all these like tests and things like that. But it just takes a little bit of time. Okay, so it's been some time, and so now it's talking to the instrument again. So you can see it's saying it's booting, it's connected, which is good. It'll probably like run through a few other things before, and you can probably, no, not yet. But some of these lights will start to like turn. Yeah, there we go. Some of these lights will start to turn on automatically as it like runs through some of these like startup tests. So you can kind of see it's like, it's going through like each part of the mass spec and making sure it's like on and working. So once it says entering main loop, that means it's ready to go. So now we can open up the tune page. And the tune page is like just controlling the mass spec. And then we can also open up Excalibur again. Alex, do you want to have the honors of being the like official controller?
Okay.
Yeah. Okay. So do you remember how to like get into that view where we can see the chromatography part of it, where we can see like the pump and the column compartment and all that?
No.
Okay, so go over here where it says S2 for Excalibur. Just click on that. There you go. Okay. So see how it's like giving you information now. So it's saying like the column is 40 Celsius. This is like the pump. So go to direct control. Just click that. Oh. Okay, perfect. So we're back in this screen. So then just hit the up arrow once, and it should go to 0.2. Perfect. So you can see the pressure's like coming up quite a lot now. The other thing you can do is if you click in here and just highlight that whole number with the percent sign and everything, yep, and then just type in 0. Okay. All right, and then just hit. You can either click somewhere or just hit enter.
Oh, there.
Perfect. Okay, so that's telling it. This is telling it like what proportion. So there's those 2 bottles up there. One was water with formic acid. One was acetic nitrile. And so that's just telling you what proportion of those bottles it's running with. What's kind of cool too is that this is a binary pump system. So when you change something like that, like you get almost an immediate change in your composition. So the pressure will change pretty quickly. But anyway, you can bump it up again to 0.3. So we're just kind of slowly, the flow rate for this method is 0.5, so we're just kind of slowly bringing it up to the right flow rate. You can technically like put it right at 0.5, but it's better for the column. Like you can kind of imagine like, you know, it'd be like if someone made you like sprint from like a stop versus like, you know, doing like a light jog to like a run to a sprint. Like it's just a little bit easier on your body. So it's the same thing with the column. All right, you can bump it up to 0.4. All right, it's looking good. And I think at this point, like this column, if I'm remembering correctly, like when it kind of stabilizes and equilibrates, like it's around like 630 bar when it's at the 0.5. So this pressure seems pretty normal. So the more you run, the more familiar you get with like the like pressure. So that's kind of something to keep an eye on to see like, oh, like today the pressure is like 30 bar higher. Like that might be a problem. So that's always something to kind of keep in mind. And you can kind of see like the pressure is starting to kind of like go down a little bit as the column gets kind of used to being under that flow rate. You can imagine the column's kind of like, it's kind of like sand inside that column, so you can imagine all of the particles are kind of like packing together, like, you know, they're kind of like equilibrating to like being under pressure, so there's a little bit less back pressure as the column equilibrates. You can bump it up to 0.5 now. That'll be our final flow rate. Okay. So that's looking like pretty good. If anything, like maybe a smidge low, but at the same time, like we've also like warmed up the column for a while too, so that could be part of the reason why the pressure's a little bit low. The other thing I'm going to do is just double check to make sure that everything's nice and tight inside here. So the thing that I look for is like if I see like a droplet of water or anything like that, like around the fittings. I don't see anything, so I think we're okay. I'm just gonna shut that. All right.
You see the like?
Oh, inside here?
Yeah.
So yeah, that's
Great place.
yeah, that's our. These are our vials, so we put them in the like green area. Okay. All right, so Alex, the next thing you're gonna do, you're gonna actually like warm up the mass spec. So if you click on this, like it's like a little tuning fork. Okay, and then if you want, you can like maximize it, like make the window bigger.
Oh.
There you go. Okay, so go into ion source. Okay, so first thing we're gonna do is we're gonna change this to negative. So just click up there. Perfect. Okay. And then I'm trying to remember, I think this is 50, so just click in here where it says, you can just click the number and type in 50. I believe this one's 20. This is 350. And this is 350. Okay, and then hit apply. You'll kind of see like the stuff that is like new, it makes it bold.
Bold, yeah.
And it usually takes a minute. I don't know why. The computer needs like time to process that. I don't know. It doesn't seem like a big ask. But you'll see like once it finishes doing that, you'll see like all of these will kind of like turn like kind of like an orange color, indicating that they're like working their way up to the new set point. The other thing too, it's probably not going to pick up in the video, but you can hear like, you kind of hear like a fan or something.
Yeah.
Like it's like kind of like a whirring noise. So that's like the sound of the source starting to heat up. Okay. Yeah, so you see how now it's like both these are orange, and you can kind of see the temperature is starting to climb up, which is good. All right. The other thing you can do too is you can hit this play button up here, and so this will actually like turn on the voltage on the probe. So you can see this is basically just like what the mass spec is seeing right now. And so if you want, just hit this like valve button, just click on it, perfect. So what you did was you turned, there's like a little valve right here. And so when it's on that like 1-2, it's going to waste. And when it's on 1-6, it's going, you can see this is the 1 port here, the number 1. There's like 1, 2, 3, 4, 5, 6. So you're basically saying go from like here to here. And then 1 to 2 is going here to here. So this is our waste line. This is our line to the mass spec. So when you hit that 1-6, like now it's actually flowing into the mass spec, and you can see there's some like just like general noise from just the solvent coming out. And you can see there's like, that's a pretty strong signal. It's just like, that's just the background jump in our solvents, which are LCMS grade, which is very clean. So that's kind of what I was getting at earlier, is that there's just so many like molecules and everything of just like random junk that hard to get rid of that stuff. Okay, so this is kind of warming up. Ideally, you'd want to like warm this up for like a good 30 minutes if you can. We have it set up in our batch where it runs a bunch of blanks before it even gets to our standard curve, so that'll kind of give it some like extra warm-up time as it's going through those samples. So if you click on the Excalibur symbol and you go to sequence setup, okay, and this is where having that spreadsheet makes it really easy. So go to File and then go to Import Sequence and then go to Browse. Go to Desktop, go to Batches, and then just sort by date modified, and it'll be the most recent one. Yeah, there you go. Just click on that. And then hit OK. And it just imported everything that we made earlier. So you can do this part in here, but it's kind of a pain in the butt because it's like you can't do the like Control F and overwrite stuff. So it's just, I don't know. I think it's easier to do it in those spreadsheets and then move it over here.
Yeah,
so,
it seems that way.
Yeah. So okay. So we'll just kind of go through. Let's just can you scroll to the bottom? Okay, yeah, I just wanted to make sure that like all these are the same, it's going to the same folder, all of these are the same, this is the right method, and then if you scroll to the right, okay, it's the same, looks like it's the same processing method, the injection volumes look good. I think this is like pretty much ready to go. And actually, if you could go in here, go to column compartment, and then change this to 35.
Oh,
yeah. There you go. Yeah, that'll work. So I think, yeah, I was looking at the pressure that we were at, and I was remembering, I'm pretty sure our method is at 35, not 40. We can actually double check that. So if you go into Excalibur again, you right click on any of these and just hit open file. It'll actually pull up our method and we can double check that.
Oh. Oh, because it's a pathway. Oh, okay.
Yeah, yeah.
Okay.
Okay, so if you go to column compartment. Oh, it is 40, okay. All right, so yeah, you can change it back, sorry.
That's, oh, here?
Yes, in there, and then just hit, you can just like double click on it so it highlights everything in there. Oh, here you go, yeah, there, that works.
There we go.
Okay. We'll just give it a second to kind of come back up to temperature. All right, and then you can actually, you can go to, yeah, go to pump. Okay, and then go back to
The tuning fork?
no,
Or
the
excalibrator?
yeah, that one. Yeah. Okay. So I think at this point we have a couple of blanks. So like even though the column compartment started to cool down, by the time it gets to our standard curve, it's going to be fine. So what you can do is I think it's this button here. Oh no,
Run
to run batch. That one, run sequence. Yeah.
Okay.
And you can see it's going from sample 1 to 46, and it's going to go into standby when it's done, which is good. And then just hit OK. Hit OK. Oh yeah, and you can just overwrite this. Just click on that and hit save.
Yes.
And then if you click on acquisition queue, you'll see now it has like a list of all the samples it needs to run.
Oh.
The other thing too that it'll take some time before it like shows anything, but you can also click this button here, and like when it starts acquiring data, you can actually see in real time like the peaks coming out. So okay, in the meantime, what you can do is you can click this tuning fork again. So you can see right now it's getting all of the like source stuff ready. And this is again like kind of a nice reason to like preheat everything so that it just takes less time when you're like preparing. So it's getting all the gas flow rates stable. Now it's going to do all the temperature stuff. This one overshot a little bit. It should be at 350, but it kind of like overheated. So it's just going to like wait until it's like within range. The other thing that's like worth pointing out is that when it's running, you can see it turns to this like kind of like sapphire color. Normally it's like green if it's just kind of waiting for stuff to happen. So that like if you ever walk in here and you see it looking like this, that means someone's probably running on it. You can hear it kind of like, you can see it's like doing stuff now where it's like, it kind of has like a loading bar. So if you go back into this one here, you'll see in a moment when it starts to like run, it'll kind of give like a little like map of the gradient.
Oh.
Yeah, there you go. So you can see this like red one is our pressure. The blue one, I think it's the like sample compartment temperature, which like, you know, that should always be at like 12 Celsius. So, but yeah, you can see you can kind of like watch the pressure in real time. Like, and this plot here is the percent B. So that's acetonitrile. So as there's more acetonitrile, the pressure will eventually go down. There's kind of like a point where it's like 80% water, 20% acetonitrile, where the pressure is actually like a bit higher. But in general, like once you get past that, the pressure, like once you get past like honestly like 50% acetonitrile, the pressure just starts to plummet, and it'll go down to like 250 bar when it's like in this area.